Alright, so we're just getting started with using System Essential tools. These are the tools that you're going to use all the time. They're the basic commands of the Red Hat or any Linux operating system, and it's going to help you get started with using the shell and the command line tools inside of Linux. Now, what is a shell? If you've never heard of the term shell again, we're talking about the bash shell, BASH, or born again shell, and that is the terminal that you're going to be using to interface with the Linux operating system to run commands. So what's a command? A command would be something like listing out the contents of a directory. You want to see the files that are perhaps written in a directory by using ls-l, and that is going to list out in a long format all of the files that are in the current directory that I'm in. So that is how I'm interacting with the shell. I'm running human readable commands, and it is executing them and providing details based on the commands that I run. And those details in this case are the contents of this directory. So if we want to do a short listing, we can just do ls. We can see that's a lot different. You know, we're not using what's called a parameter or a switch on the end of that command. That -l is a switch that is providing the shell information to say, hey, I want to look at this content in the long form, which includes the permissions, it includes the owners, and how big the files are. We can even add other switches to the end of it, like an H. If we do ls-lh, it's going to show us human readable format, so you can see that we're given the file size of each of the files that are in there, which is a lot easier for us to determine whether or not a file is perhaps taking up too much disk space. I'm kind of curious, do you guys like this freeform presentation? You know, it's not really smooth. I don't have anything scripted. I'm just kind of reading through the notes that I took, and I'd like to know if you guys think that that's a preferred format, or do you want something clean? I'm going to do this video just like this. The next video, I'm going to do a clean one, and if you guys could, in the comments, let me know which one you like better, and I'll stick with that format. Alright, so that is how we interact with the shell. The first thing we talk about is internal, external, and alias commands. Let's talk about that. Alright, so what the heck is an internal and external and an alias command? Well, starting with an alias command, an alias is kind of like a name that somebody gives you that's not your real name. We can do the same with a file. We can create a command, not a file, a command that we can define as one thing, an alias, to another command. So let's see how that's done. If I type alias, and then we'll do listed equals ls-ltrh, and hit enter. First of all, we get a error message, and if you don't run a command correctly, this is basically what you'll see. So one of the bits of this command are wrong. I know what that is. It's the spacing between this. And this is just to show you that when you run a command in the command line terminal of the Linux operating system, it has to be exact. So if I run this again now, with that space removed, it took it. And we know that it took that command because it didn't spit out an error message. Now, we have a new command called listed that's going to run our ls command with the L, T, R, and H flags set on against that command. So if I do listed, we can see that it's listing out all of those files in the order in which they were last updated. So we can see that I have a file in here called protocol bill, and its time that it was edited was 9:40. The newest files are at the bottom with that command. We have the L for listing out of the files, the R and the H. I don't remember if the T or the R is the flag that is listing these out in the order in which they were written, but we can always look at that with the man page, and we'll cover that pretty shortly here. So that is the alias command. The other two commands that we have are internal and external commands. An internal command is a command that is built into the shell, and the book basically describes that as something that is quicker to run, and I imagine that's because it's probably loaded into memory when the operating system boots up. Versus an external command, it's sitting on the disk or the hard drive or solid state drive. It's not part of memory. It's sitting on a disk, and it's a command that can be executed based on a path variable. Where does it live on that disk? And we'll talk about that in a second as well. So we can figure out if a command is internal or external using the type command. If I type and do pwd for present working directory, we can see that that is a shell built in. That's built into the shell. So if we take a look at another command like uptime, and this is going to show us the path to that command, where that command is sitting on disk, we can do type pwd, and we can see, well, sorry, pwd, we just did uptime. We can see that the path to that is on disk on the usr bin uptime directory. And if we do ls usr bin, we can see that there's a whole bunch of commands in that directory that are sitting on disk. The way that the operating system determines where to look for those commands, so when I type a command, you notice that I don't have to type out the whole path to the command, right? So if I do which uptime, it's telling me that that command is in usr bin uptime. I can run uptime without defining the full path. See that? That's showing me that the system has been up for an hour and 48 minutes. Why is that? That's happening because there's something called a path that's defined for each user by default. And it defines where the shell is going to look for any commands that you run. Each path that is defined in your path, or each directory that's defined in your path, will be checked for that command. And based on what I was reading and did some research on this, it will execute the alias commands first. So there's an order of preference here. I believe it goes alias, and then it's going to go your built-ins, and then your I should say your internal commands, and then your external commands are going to be the last ones to execute. So if we wanted to run this same command using the path, it's going to give us the same results. usr bin uptime, and there we go. It's doing the same thing. But we don't have to type that out, because for each of our users, there's a path defined in a variable for where the shell is going to look, and we can see and look at that with the echo command. And echo is just kind of like printing out either what you define to print on screen, or it's going to print out some value of like this. This is a variable path, and we can see that each of the directories that the shell is going to look in is listed here. We have home b Saint Germain .local bin, home b Saint Germain bin, usr local bin, and there's usr bin. It's the fourth one, 1, 2, 3, 4, fourth or fifth one to the right there, right? I'll point an arrow to this once I edit it, but that's the directory that it's looking in when we're executing that uptime command. And the which command here defined that for us as well, which is probably a lot easier to look at than trying to figure it out via the path. So that pretty much wraps this up. The only other thing that I want to mention, and this is probably a little more advanced, and we might get into this later as we write scripts, but if you do a // the dot means in this current directory. It says look for whatever command I'm defining. So if I navigate to usr bin, I don't have to do this because it's in my path, but let's say that you did have a script that you wrote that wasn't in the path that you were working off of in your path variable. You would have to do dot, the current directory I'm in, and then / the command that you want to execute. So in this case, we'll do uptime, and you can see that it would also execute whatever command or script that you had in that directory that you're sitting in. I don't know how to write scripts yet, but we'll get there. Next, we're going to talk about input-output redirection, and there's 3 types that we're going to talk about. There's standard output, standard error, and standard input. Standard output is anything that is put on your monitor, and it can be redirected to any place with these commands. I don't know if you can see this, hopefully you can, but it is the this symbol here, and that stands for writing the standard output to a destination. So if I wanted to say echo, remember we said the echo command could be used to display stuff. I'm going to display this or output it onto the screen. Hello, please subscribe to my channel, right? And we'll redirect that. Instead of printing it on the screen, we're going to redirect it to a file called subscribe. And I got permission denied because I forgot to navigate to my home directory. Let's do that. I'm going to do change directory by itself. That will put us in our home directory. PWD shows us that is home B Saint Germain. And if we push the up arrow twice, or 3 times in this case, we can get that command back so I don't have to type that all out again. Hit enter, and you notice that nothing was output. We redirected that output that would have been displayed otherwise. So if I take this out, take this redirector out, the output is now on the screen, which is the default. By using that redirector, we're taking that standard output and putting it into a file. We're redirecting it with that command. So if I do cat subscribe, we can see that that message was written to that file. We redirected that output to that file. Now, there's one other command that we're going to show you that is a standard redirector output command. And if I do hello, please subscribe, pretty please, and hit enter. Now, using the same command, what do we think is going to happen there? Well, let's take a look at what's inside of that file. We're going to cat out that subscribe. Cat stands for concatenate. We're just spitting out what's the content of that file. And you can see that the previous message, hello, please subscribe to my channel, is now overwritten. So we know that that redirector with a single arrow to the right there overwrites anything in that file. What if we wanted to append to the file? What if we had a lot of different messages we wanted written to that file? Well, we put this an additional arrow to the right here, and we can put our old message back in there. Hello, please subscribe to my channel. And now the message will be appended. It didn't overwrite that file. So that's standard output redirection, and that's what standard output is. Next one is standard error. Standard error is an error message that is displayed on screen due to some condition. So if I did ls hello, I'm looking to list out the file. I want to take a look at that file, see what it's about, and it says that file doesn't exist. That is standard error displayed on screen. Now, there's a special way that we need to get rid of standard error messages. A lot of times you don't want to see standard error messages on your screen, and we can redirect that to the recycling bin of the Linux world, which is dev null. So I'm going to do hello again, but this time we're going to use this redirector, which redirects standard error to dev null. And now it doesn't display anything. There is nothing displayed there because it sent that error message to the void. It's just a place that doesn't have anything. It just essentially wipes it out. And if we want to additionally, we want to say write both the standard error and standard output to a file. We could say ls hello. All right, we want to take a look at that, but we also want to see the contents of home B Saint Germain. And we're going to say redirect any error messages to the nether, and then we want to redirect any standard output to let's see. Let's see. All right. So now we are redirecting 2 different streams of data, one to the garbage can in dev null, and the other to which is standard output of listing out the contents of my directory. Let's see what's in there. Cat let's see. And we can see that the only thing that it captured, because it's redirecting 2 different streams, is that standard output. We have all of the contents of that directory now listed into that file. I hope that makes sense. If it doesn't, hit me up in the comments and let me know if I didn't explain that clearly. I hope I did. Alright, so we've covered standard output and standard error. There's one more that we need to cover, and that is standard input. Standard input is a simple one. We basically take some file and feed it into a command. Rather than using the right arrow, we're using the left arrow, and in this example we're going to use the sorted command, which is going to sort the contents of a file for us. So let's take a look at that file first. I'm going to cat out this file called counted, And we can see that there is a list of numbers and some letters in there, 1 through 6, but they are not sorted correctly. We can use the sort command, sort, and feed in our file into it, which kind of makes sense, right? It's like kind of feeding the command the data, and it's going to take that data and put it into standard output for us. So we can see after redirecting the content of that file into the sort command, it is now listing out the numbers, correct order, 1 through 6, and that's pretty much it. I'm sure there's more that you can use that command for, but for simplicity, that's what it's all about. Alright, the next command is an essential one. I use it all the time, and that's the Linux pipe command. The pipe command is capturing data that's output by one command, allowing you to process it by another, and I think that's just easier described with an example. Let's go ahead and cat out our counted file, and you can see by default it prints it on the screen as we've seen many times before. We can add a pipe in there to process it by another command. We'll do grep, and we're going to look for the word second. So it's going to grab that outputted data and search with a grep command for the word second and print those matches on screen. And we can see that happened right there. But what if we wanted to add even more processing of this command? Maybe we'll look for the word -i to ignore case and look for the word this. And then further, we want to capture that data that's processed with another pipe and number each line before it's output onto screen. Let's see what that looks like. That's pretty cool, huh? So now we've actually captured data twice with 2 different pipes. One to process the data that's output from cat counted. Then the second one is going to process the data with a number line command. After grep has done its job, it's going to pass it on to number line, and number line is going to take its responsibility of numbering each line that's output onto screen, as you can see here. So that's pipe in a nutshell. I hope that makes sense. I'm wearing a different color hat, and we're going to talk about history. I actually recorded this and then re-recorded it because I learned something as I was actually looking at the training video I made. I said, that doesn't make sense. Let me circle back and take a look at that. So, to look at the history, all of the things and commands that you've run in your Linux terminal, we run the history command. And we can see that numerically the history command is stored. I call this the history cache. These are all the commands that you've run in this particular terminal session. After you log out, it takes all of the commands from your history cache and writes them to a hidden file called .bash_history. We can see all of the hidden files in our directory, and those are files that start with a period in Linux are hidden with the ls-oh. So we can see here hidden file .bash history is in our current working directory, and if we cat that out, we can see that the buffer is currently empty, and that's because I wiped it out before I started this training video. Let's take a look now. If we look at our current history cache for this session and we log out and then log back in again, we'll see that the history cache, or the history cache, has been written to that .bash history file. So just wanted to kind of explain how those two pieces work. You have your cache with your current session, and you have your .bash_history that is written to disk when you log out of your terminal. So we still have all of our history commands in here. If I want to do a reverse search on perhaps a command that I've run, I can do Control-R and just type in like any of the commands that you kind of see above, and it's going to match up on the most recent match on, in this example, the command cat. And if I hit enter on that, it's going to execute that command for me. Another thing that you can do, if we take a look at the history, is delete particular entries in there. So if I have a couple of terminals up, and that happens all the time when you're working in the tech field, you do multitasking, and I accidentally type in something like this, a password for another terminal, and I accidentally hit enter here. Now it tells me that the command is not found. This would have been a password for another terminal that I just accidentally entered into this terminal, and what happens, even though the command is not a valid command, it still logs it in the terminal history in the cache. But it has not yet been put into the .bash_history file. we can see that the .bash underscore history file does not have this particular entry, index number 19, in its file because I haven't logged out and it hasn't written there. And if I want to make sure that it doesn't get written to the .bash underscore history file and I want to remove it from my history cache, I can do history minus D and the number of the command that I want to delete. Now if we run history, we can see that that command is no longer there, just to show you that it wouldn't be in here regardless because I haven't logged out yet. It's not in the bash history, and if I log out and back in again, now we've pushed that history cache over to our bash underscore history file. Since I deleted that command, that accidental password entry, it won't be in the bash underscore history file. It's not there. So if we want to delete both the history file, the bash underscore history, and our cache, we have to do something. We have to first clear out all of our history, and then we have to do history minus W. So what this is doing is it's clearing out our cache, so there's no commands in our cache, and it's pushing that and overwriting the bash underscore history file. Now the bash underscore history file is empty, with all but the history minus W command. And there's really no way around that. I think that's a security feature because what you're doing is you're clearing out the history cache and then you're running history minus W, which is pushing down this command that you just ran. And you know, that's probably a good security feature. If you log into your system, you're like, why is there no commands in here? Let me take a look at the bash history file. Oh, somebody ran history minus W on a shared account, for instance, where multiple people might be sharing the same local login. That gives you a clue as to what happened. Other than that, the only other command that I really wanted to talk about was a command that just automatically executes that starts with some sort of a match. So let's say I do a date, right? I'll run history, and if I do an exclamation point, and this time rather than putting in the number, actually I didn't show that either, you can use the exclamation point followed by one of the numbers in the index to re-execute a command. So that's a pretty nice and quick way to re-execute long commands. You can also use the exclamation point to execute on matches. So if I do cat, it's not going to search for it. It's just going to automatically execute on whatever matches, the best match, and I think the most recent match. And obviously that can be really dangerous if you're not looking at the history and it runs some sort of command that you weren't really expecting it to run. So be careful with that one. But that's pretty much it. That's the history in a nutshell. I hope that all made sense. That ends this video. I want to thank you all for checking out my video, making it this far to the end. If you liked it, please consider subscribing and hitting that thumbs up button. I would really appreciate it. We'll see you in the next video.